This is the 2019 MEXT Undergraduate Mathematics A paper. Let's get started. Section 1, Number 1. Since we are throwing a die 4 times, there are 1,296 possible outcomes, and we need to determine the probability of ending up at the origin. The first scenario is that the fourth number is a 6. The number of permutations is 6 cubed to 16. The second scenario is that we get 2 pluses and 2 minuses. There are 6 ways of arranging 2 pluses and 2 minuses. Either a 1 or a 2 or a 3 can result in a plus. 3 times 3, either a 4 or a 5 results in a minus. 2 times 2. And 36 times 6. So we get 216 again. And the final scenario. The first number can be any number, the second number must be 6, and the third number is either a plus or a minus, and the final number is either a minus or a plus. So, the first number can be any of the 6 numbers. We can ignore the second number, and we need 1 plus and 1 minus times 2, 72. So let's add these 3 numbers and then divide the sum by this number. The answer is 7 over 18. Number 2. Let's ignore the absolute value sign so that we can visualize what's happening. So we have a cubic function. And let's factorize. So the graph of this cubic function looks like this. And since this part is inside the absolute value sign, this portion of the curve needs to get flipped upside down like this, so that the graph stays above the horizontal axis. And next, let's differentiate this cubic function in order to find the coordinates of the turning points. Let's use the quadratic formula to find the value of x. Now let's find the y-coordinates of these 2 points. So the y-coordinate is 2 root 3 over 9. And since this portion is flipped upside down, the y-coordinate of this point is also 2 root 3 over 9. The right-hand side of the equation is a constant k, and the number of real solutions to this equation is going to be maximum when k is within this range. So between 0 and 2 root 3 over 9. And in this range, there can be up to 1, 2, 3, 4, and 5 solutions. Number 3. In this question, we have an angle theta, which is between 0 and pi, and we have a triangle ABC. The area of the triangle ABC can be expressed as 1 over 2 times the magnitude of the cross product of vector AB and vector AC. So let's try to express these 2 vectors. The x component is 1 minus cosine theta, and the y component is 0 minus sine theta, which is minus sine theta. 1 minus cosine 2 theta, 0 minus sine 2 theta, which is minus sine 2 theta. There are 2 useful trig identities that you should know. Sine 2 theta is 2 sine theta cosine theta, and the other one is cosine 2 theta is 1 minus 2 sine theta squared. vector AC can be rewritten as 1 minus 2 sine theta squared and minus 2 sine theta cosine theta, which is 2 sine theta squared minus 2 sine theta cosine theta. Next, let's find the cross product of vector AB and vector AC. Recall that the cross product of vector A and vector B is the x component of A times the y component of B minus the y component of A times x component of B. Therefore, 1 minus cosine theta times minus 2 sine theta cosine theta minus sine theta times 2 sine theta squared. Cosine theta squared plus sine theta squared is equal to 1. So the cross product of vector AB and vector AC, 2 sine theta times 1 minus cosine theta. And what is the magnitude of this new vector? The magnitude of a vector is the sum of the squares of its components. So let's square this number. So the area of triangle ABC is sine theta times 1 minus cosine theta. Next, let's try to find the value of theta. In order to find the maximum area, we need to differentiate this expression that we just found with respect to theta. Since this expression is the product of two numbers, we need to use the product rule. So, what is u? U is sine theta. What is u dash? The derivative of sine theta is cosine theta. And what is v? V is 1 minus cosine theta. And what is v dash? The derivative of cosine theta is minus sine theta. Cosine theta times v, 1 minus cosine theta, plus u, sine theta, times v dash, sine theta. Now, sine theta squared is 1 minus cosine theta squared. Cosine theta is 1 and cosine theta is minus 1/2. When cosine theta is 1, theta is 0, and when cosine theta is minus 1/2, theta is 2 pi over 3. If the angle is 0, there won't be a triangle, so the angle must be 2 pi over 3. And let's substitute this value of theta into this equation to find the maximum area. So the maximum area is 3 root 3 over 4. Number 4. We have a number 2 raised to the power of k times some prime number p, and we need to find the sum of all the divisors of this number. This number can be divided by 2 to the power of 0, 2, 2 squared, 2 cubed, all the way up to 2 raised to the power of k. And it can also be divided by 2 raised to the power of 0 times p, all the way up to 2 raised to the power of k times p. Since all these terms have p as a factor, we can take p out of them. You need to notice that this portion and this portion are identical. 1 plus p times the blue portion. Next, let's try to simplify this portion. When k is 1, 2, when k is 2, when k is 3, 3 is 4 minus 1, which is 2 squared minus 1, and 7 is 8 minus 1, which is 2 cubed minus 1, and 15 is 16 minus 1, which is 2 raised to the 4th power minus 1. So this portion can be expressed as 2 raised to the power of k plus 1 minus 1. So the sum of all the divisors of this number is 2 raised to the power of k plus 1 minus 1 times 1 plus p. Number 5. In this question, there are 10 cards in a box, with numbers from 1 to 10 written on them, and we randomly take 3 cards out of the box. And we need to find the probability that x is less than or equal to 3. How many possible combinations are there? Out of 10 cards, we are choosing 3. So 10 choose 3 is 120. When x is 1, y and z can be between 2 and 10. So we are choosing 2 out of 9. When x is 2, between 3 and 10, 8 choose 2. When x is 3, y and z can be between 4 and 10. So 7 choose 2, which is... And let's add these 3 numbers and divide the sum by 120. This equals 17 over 24, and this is the answer. Number 6. We have a sequence 1, 4, 10, 19, 31, and so on. And we need to find the sum of the first n terms. So let's examine what's happening in this sequence. The difference here is plus 3. The difference here is plus 6, plus 9, plus 12. So the difference increases by 3 each time. When the difference of differences increases by a constant, the sequence can be represented by a quadratic function. The first term is 1, the second term is 4, and the third term is 10. And we can substitute these 3 pairs of values into this formula. And we have to solve these 3 equations simultaneously. So now we have the equation for finding the nth term of this sequence. So what is the sum of the first n terms? The sigma can be distributed. Now, in order to solve this question, there are 3 facts you need to know. Firstly, the sum of natural numbers up to n is n times n plus 1 over 2. Secondly, the sum of the squares of natural numbers up to n is n times n plus 1 times 2n plus 1 over 6. And thirdly, this is equal to n. So, since this is going to be quite a tedious calculation, I'm going to skip to the answer, and you can try to figure out the intermediate steps yourself. So this is the answer. Number 7. So let's simplify these fractions. 4a over b plus b over 2a minus 1. And to find the minimum value, let's differentiate this with respect to b. And let this be equal to 0 and solve this equation for b. Now the question states that both a and b are positive, so b is 2 root 2 times a. And finally, let's substitute this value of b into this expression to find the minimum value. So the minimum value is 2 root 2 minus 1. Number 8. Let's first of all consider the expansion of this binomial. When n is k, the coefficient is k choose 0 times x to the power of k, and we can ignore 1, plus k choose 1 times x to the power of k minus 1, and so on, k choose k times x to the power of 0. So this portion is basically this. And since these two terms can be swapped, we can also say x to the power of k as well. And because this version is slightly simpler, let's go with it. So the answer is x to the power of k. In the second part, we have an expression that is very similar to the first one. The only difference is this part here. Based on this information, we know that x is 2. Therefore, by substituting x equals 2 into this binomial, we get 2 plus 1 to the power of n, which is 3 to the power of n. And the question says that we need to consider the derivatives of the first equality with respect to x. What this statement probably means is that we need to differentiate the left-hand side as well as the right-hand side of this equation. So let's start with the left-hand side. N times x plus 1, subtract 1 from the exponent, times the derivative of x plus 1 is 1, n times x plus 1 to the power of n minus 1. Next, let's differentiate the right-hand side. So we basically brought k to the front and subtracted 1 from k. And these two expressions must be equal to each other. Let's multiply both sides by x. Now when x is 2, we have this. And let's multiply both sides by 3. Now 3 to the power of n is equal to this expression here. So let's replace this with this. And divide both sides by 3. And the right-hand side is identical to the left-hand side of this equation, and the left-hand side of this equation is very similar to the right-hand side of this equation. Therefore, 2n over 3. Number 9. When you divide a base 6 number by d1 with no remainder, you get d1 times quotient q1 plus 0. And the base 6 number can be represented as, let's call this equation number 1. And secondly, we are also told that the sum of all the digits of this number can be divided by some number, let's call it d2, with no remainder. So d2 times quotient 2, and the sum of all the digits of a base 6 number is simply x sub k where k goes from 0 to n. Let's call this number 2. And from 1 we get, and from 2 we also get, the left-hand sides of these equations must be equal. So we have this. Now let's consider 2-digit base 6 numbers. For example, 1, 0, 1, 1, 1, 2, and so on. 6 plus 0, which is 6. 1, 1 is 7. Next, let's consider the sum of all the digits of each of these numbers. 1 plus 0 is 1. 1 plus 1 is 2. What are the common factors of 6 and 1? 1. 7 and 2, just 1. 8 and 3, 1. 9 and 4, 1. 10 and 5, 1 and 5. 11 and 6, just 1. So we can see that a base 6 number is divisible by 5 if and only if the sum of all its digits is divisible by 5. Therefore, D1 is 5 and D2 is also 5. So this part can be rewritten as 5Q1 minus Q2. Next, let's think about Q1 minus Q2. Because Q1 is 1/5 of the base 6 number and Q2 is 1/5 of the sum of all its digits, Q1 minus Q2 is 1/5 times the base 6 number minus the sum of all its digits. Six to the power of 0 is 1, so 6 to the power of 0 minus 1 is 0. So this term disappears. So this can be rewritten as this. Now, the last step is quite tricky, and you need to know this formula. So, by shifting 1/5 over here, we get this. And 5 is 6 minus 1, so we can use this formula. And the question uses L as an index, so let's use it. So now we have this. We have the answer. Number 10. Let's try to visualize what is happening in this question. Let's express y in terms of x. Now this linear equation is very similar to y equals minus x, because the coefficient of x is really close to minus 1 and the y-intercept is a very small number. So the graph of this linear equation will look something like this. So what can we infer from this information? When the absolute values of x and y are very small, they will be identical to each other. For example, 1, minus 1 and minus 1, 1. But as you move away from the origin, the difference between the absolute value of x and the absolute value of y will get bigger. So let's consider the case where the absolute value of x minus the absolute value of y is exactly 1. If we assume this equation to be true, then there are two possibilities. 1, x is positive and y is negative. In this case, x minus x is 1, that is, x plus 1 is 1. And the second case is where x is negative and y is positive, in which case minus x minus y is 1. So let's substitute these two values of x and y into here. This is equal to minus 84. So let's plug this number back into this equation to get the value of x. Next, let's examine the second case. Now 254 is not divisible by 3, so 2 cannot be true. So the answer is x is 85 and y is minus 84. Number 11. We are moving the graph of y equals 2x squared plus 3x plus 1 2 units in the x direction and minus 3 units in the y direction. So let's first of all consider a, the coefficient of x squared. Because we are not changing the shape of the parabola or turning it upside down, the coefficient of x squared should stay constant, so a should be 2. Next, let's consider the y-intercept. When x is 0, y is 1. Therefore, this parabola goes through the point 0, 1. So let's shift this point by 2 units in the x direction and minus 3 units in the y direction. 2, minus 2. Next, let's find the coordinate of the vertex of the original parabola. The x-coordinate of the vertex can be found by using this formula. And let's substitute this value of x into the equation here. So the vertex of the original parabola is at minus 3/4, minus 1/8. Just like we did with the previous point, let's shift the vertex by 2 units in the x direction and minus 3 units in the y direction. So this is the new vertex. So let's substitute these two pairs of values into this equation to find the values of b and c. And let's solve these two equations simultaneously. Let's multiply both sides of this equation by 4. Therefore, b is minus 5 and c is 0. Section 2. In part 1, we need to use this fact to find the value of cosine pi over 12. You need to know the following formula. Cosine alpha minus beta is cosine alpha times cosine beta plus sine alpha times sine beta. Therefore, cosine pi over 12 is cosine pi over 3 minus pi over 4, cosine pi over 3 times cosine pi over 4 plus sine pi over 3 times sine pi over 4. Cosine pi over 3 is 1/2, cosine pi over 4 is root 2 over 2 plus sine pi over 3 is root 3 over 2 and sine pi over 4 is root 2 over 2. Cosine pi over 12 is root 6 plus root 2 over 4. Let's look at the second question, in which we need to find the length of AC. AC is the side here. Let's call this point D. Because triangle ACD is a right triangle, cosine pi over 12 is the adjacent AD over the hypotenuse AC. And we know that AD is root 6. And from part 1, we know that cosine pi over 12 is root 6 plus root 2 over 4. so AC is 6 minus 2 root 3. In the next part, we need to find the square of the length of BC. We need to use the cosine rule, which states that c squared is a squared plus b squared minus 2ab cosine c. So bc squared is ab squared plus ac squared minus 2 times ab times AC times cosine pi over 12. Again, this is going to be a tedious calculation, so I'll skip to the answer, and you can work out the intermediate steps. BC squared is 56 minus 32 root 3. In the final part of section 2, we need to find the length of BC. From part 3, we know that BC squared is 56 minus 32 root 3. Therefore, BC is root 56 minus 32 root 3. Now, because we have a square root inside a square root, to be able to simplify this expression, you need to know the following fact. Root a plus root b can be expressed as root x plus or minus root y if and only if a squared minus b is the square of some rational number c, in which case x is a plus c over 2 and y is a minus c over 2. So let's try to put 33 back into the square root. 32 root 3 is root 3072. So let's see if 56 squared minus 3072 is the square of a rational number. The answer to the question has turned out to be yes, this is equal to 8 squared. So the number c in this question is 8. So x is 56 plus 8 over 2, which is 32, and y is 56 minus 8 over 2, which is 24. Therefore, BC is root 32 minus root 24, which is 4 root 2 minus 2 root 6. Section 3. Now, the question states that f of x is a quadratic function, meaning that the antiderivative, capital F of x, must be a cubic function. Capital F of x has extreme values at x equals minus 2a and 2a. The last piece of information tells us that the graph of the antiderivative, or capital F of x, is going to look something like this. Therefore, if you input a negative number into this function, like minus x, let's call the corresponding y value just y, then we will have another point such that the signs of x and y are inverted. Therefore, this is equal to minus capital F of x. And another useful fact that you should know is that when the graph of a cubic function is symmetric about the origin, the equation of the cubic function will be something like this. But in this question, we don't really need to worry about the coefficients of x cubed, x squared, and x. We can ignore these values and instead consider this much simpler version. To verify this answer, let's expand these brackets. And let's substitute minus x into the function. So now we know that this answer must be correct. we need to find all the values of x that satisfy this equation. Let's move the second term to the right-hand side. Now, from the previous part, we know that minus f of x is f of minus x. Therefore, minus f of 2a is f of minus 2a. Therefore, one of the values of x that satisfy the given condition is x equals minus 2a. Now, the cubic function, f of x, can be expressed as x times x plus alpha times x minus alpha, which is x cubed minus alpha squared times x. So, f of 2a is 8a cubed minus 2a alpha squared. Multiply both sides by minus 1 and we get this. We know that f of x is equal to minus f of 2a. Therefore, this and this must be equal. Now, let's consider the quadratic function. We can obtain it by differentiating the cubic function. Now, the question stated that the extreme values of the cubic function are at x equals plus and minus 2a. Therefore, f of plus and minus 2a must be 0. 3 times 2a squared minus alpha squared is 0. So now we know that alpha squared is 12a squared. And let's substitute this value of alpha squared into this equation. In order for the left-hand side of this equation to be equal to the right-hand side, x must be a times some constant, let's call it q. Now, q cubed minus 12q must be equal to 6. Now, since we know that x is equal to minus 2a is aq. Therefore, q is minus 2. So this polynomial must be divisible by q plus 2. So let's do some quick long division. Q squared times q is q cubed. Q squared times 2 is 2q squared. 0 minus 2q squared is minus 2q squared. Minus 2q times q is minus 2q squared. Minus 2q times 2 is minus 4q. Minus 12 minus minus 4 is minus 12 plus 4, which is minus 8. Minus 8 times q minus 8 times 2. So this cubic function can be factorized as q plus 2 times q squared minus 2q minus 8. So let's factorize this part. Q plus 2 squared times q minus 4. Let's plug in this value of q into this equation and we get x equals a times 4 or 4a. So this is the other solution. Section 3, Part 3. In this question, we need to find the local maximum value of function f of x over f dash of 0. Let's simply substitute these values. We need to differentiate this function with respect to x, and let this be equal to 0. Now we know that alpha squared is 12a squared. Since we are dealing with the maximum value, we will pick the positive version and substitute this value into this expression. Again, alpha squared is 12a squared. So this is the answer, and thank you for watching this video, and if you have any questions, please let me know in the comment section below, and see you next time.